Zener Diode. Zener Diode means, already in earlier videos we discussed about that PN junction diode means whenever the two P type of a semiconducting material and N type of a semiconductor material is doped, then we can get the PN junction diode. Then what is Zener diode? Actually, what is the use of Zener diode and why do we need a Zener diode? Means whenever the PN junction diode is connected into different bias, means either forward bias and reverse bias. In forward bias, due to the repulsion between the positive terminal and the positive P type of a material, due to that the conduction depletion layer width will be decreases. Then due to the majority charge carriers in that type of materials will move to the another region, due to attraction between the two opposite terminals, opposite charges. So here in case the PN junction diode is connected in reverse bias, due to the attractional force between the positive terminal of the battery to the negative side of, means N side of a semiconductor, and negative terminal of the battery and P type of a semiconductor, means this if reverse biased. Whenever the reverse biased, due to the minority charge carriers, a small current will flow through the circuit. So due to that the depletion layer width will be increases, then the potential barrier is also increases. We can get the output is nil, means there is a zero output we can get, and also due to the sharp breakdown will be happen due to the minority charge carriers, that junction will be breaks down. So due to avoid that breakdown, to the keep the voltage at constant, we just need a Zener diode. Zener diode means a scientist named Zener has invented this Zener diode. He did the experiment by using the PN junction diode is heavily doped. Means the PN junction diode is heavily doped on both sides, either P sides and N sides, by the impurities that can be changes. The reverse current is having increases sharply. Whenever the PN junction diode is doped heavily, then the Zener diode can be formed. Due to the doping heavily, the reverse means reverse current having this, the reverse current is increases sharply. So that's why here it can operate the system continuously without any damage. So here it is that the Zener diode can be used to run the junction without damaging the circuit, to keep the constant voltage. Zener diode can be used that can be operated in a reverse bias only. If in case of this the Zener diode can be connected in a forward bias, that is also can be act as a normal PN junction diode. Whenever we connected in reverse bias, then the Zener diode can be it like ordinary diode, except that it is heavily doped, so that have sharp breakdown voltage called Zener diode. Means it is having the sharp breakdown voltage. Whenever it is heavily doped, the diode is having very sharp breakdown voltage. That breakdown voltage is called as a Zener diode. And also this diode, this is the symbol of the Zener diode, whenever the same as PN junction diode, but the N side of a material, this P side of a material and N side of a material. N side of a material is can be denoted as a curved like Z. Z means Zener, like Z. Z means that's a Zener. It can be denoted as this symbol of Zener diode. This is the symbol of Zener diode, so that it can be operated in reverse bias only. Always it can be operated, must be operated in a reverse bias only. Whenever it is reversely biased, then it is having the diode will having the sharp breakdown voltage, so that it can be called as Zener voltage. And Zener diode is always used in a reverse bias, so that it is also used for the voltage stabilization, means as a voltage regulator or voltage stabilization. to stabilize the voltage, it can be used. Like nowadays we are using the voltage stabilizers for the electronic gadgets. If we get the more current into at home, then that can be passed through it constant supply to the electronics, TV or fridge or whatever the electronic gadgets, to avoid the breakdown, to avoid the short circuit, to avoid the damage. So we will use the stabilizers. That is the voltage stabilizers. In that voltage stabilizers also we will use a Zener diode. So in case of, by using this here, whenever it is forwardly biased, it is act as a normal PN junction diode. Whenever it is connected in reverse bias, it is flowing through this. It is independent of, means whenever the voltage across the voltage, drop the voltage across the Zener diode, it is independent of the current flowing through the diode. So that way voltage remains constant. So here it is also, whenever the voltage is moving like this, then current, whenever the voltage potential drop across the Zener diode, then the current will independent of the current. So that's why it will be constant current flow will be occurs. So here the Zener diode can be used as a voltage regulators to stabilize the voltage, to keep the voltage at constant. The voltage regulator means Zener diode is a voltage regulator or voltage stabilizer. This is the circuit of a voltage stabilizer. Here this will be Zener diode, this is P side, this is N side. When the current is connected, it can be connected in reverse bias. So that's why the P type of a material can be converted to the negative terminal, and negative N side of a diode can be connected to the plus terminal. So whenever this is connected, then here the current flows, already we know that this positive terminal to the current flows, that is IZ is the Zener current. The current which is flowing through the Zener diode is called a Zener current. So whenever it is passing through, whenever this current is flowing and so another current is also flowing through it, then this will be the load current, and the total current will be, means here I is equal to IZ plus IL can be calculated. So that's the flying current moving like this. Then the output voltage can be taken at the V out, that is RL resistance. that is Vz, we can get the output. So that Zener diode used to get a constant voltage output from source when whose voltage may vary over a wide range. Means whenever the large potential drop across the Zener diode, then the Zener diode will flows the current, allows the current constantly without any increasing, decreasing. The flow will be, the current will be constant. So that's why we will use the Zener diode as in a voltage regulator. And also arrangement of the Zener diode. Zener diode means here the Zener voltage Vz is connected across the load resistance. This is the load resistance, right? So across the load resistance RL, across which is constant voltage desired. Here the constant voltage which can be desired. So that's why when input voltage varies, means increment on decrement of means whenever the alternating current given to the system or circuit, then the input voltage will be varies. The Zener diode changes its resistance by creating the charge carriers in the diode. When the input is given to the system or input is apply alternating current is whenever connected to the system, then the Zener diode will create the mobile charge carriers. In that case of mobile charge carriers, so that it can be changed its resistance as per this. By creating the charge carriers, it keeps the voltage at constant. So that's why here when input voltage varies, the Zener diode changes its resistance by creating charge carriers inside and keep voltage constant. That means here whenever the alternating current is applied to the input, then we can get the output will be remains constant, because of here this will resist the flow of more charge. Other than the keeping the constant voltage, it cannot be allows the more voltage through it. So that's why here the Zener diode can create the more mobile charge carriers, which is equal to the Zener voltage means it gives the constant current. If we get that whenever the voltage is more, then if whenever the electronic devices which are connected to stabilizer, the electronic gadgets could not damage, because of the stabilizer will stabilize the voltage which is connected to the electronic device or home appliances, and so that can be stabilized. If we get the more current through the pole, from the pole wire, then that cannot allow that much of current to passing to the home appliances, electronics. So that's why that is the stabilizer. Stabilizer means it stabilizes the voltage. So here that the Zener diode used as a voltage regulator or voltage stabilizer. In circuit, this is RL is connected parallelly, so that output we can get it is really equal to the Vz. Either we can get that, here is also we can get like this also. Here is that also we can get the output. Here we can get the output. This is the load resistance and this is the input. This is about a Zener diode and why the Zener diode uses as a voltage regulator or a voltage stabilizer. Once again, the heavily doped PN junction diode on both sides and P sides and N side can be known as Zener diode. Due to that heavily doping, the diode will having the reverse current will increases sharply, means that breakdown is having that sharp breakdown will be having, then the voltage having that sharp breakdown voltage, that voltage is called as a Zener voltage, and this is the symbol of a Zener diode. And also Zener diode must be connected in reverse bias, because of whenever the diode is connected in reverse bias, then only we can get the sharp breakdown voltage. Otherwise it can be connected in forward bias, the PN junction, which allows the flow of current, or which it will be there voltage we can get. But in case of reverse bias we cannot get the voltage, so that's why it must be connected in a reverse bias only, so that to keep the voltage at a constant. So that voltage stabilization purpose means, what is voltage stabilization means, the device which is used to stabilize the voltage, that is called as voltage stabilizer or voltage regulator. This is Zener diode can be used as a voltage regulator. This is the circuit diagram. Across the Zener diode, the input is parallelly connected and output is also load resistance. The output is also connected parallelly to the load resistance. So that the Zener diode is connected reverse bias, because the positive terminal of the battery is connected to the N type of a semiconductor material, and a negative terminal is connected to the through the external resistance R, we connected to the P type of a material. So that here whenever the Zener diode can be connected, when the alternating current is connected to the circuit, then by changing the resistance of the Zener diode, by creating the mobile charge carriers inside, it changes its resistance and which does not allow the more voltage through the Zener diode. So that keeps the current will independent of, current is flowing through the Zener diode is independent of the potential drop or voltage drop across the Zener diode. So that's why here the constant voltage can be kept by the Zener diode. So that's why that Zener diode used as a voltage regulator, means to the reverse current increases sharply without damaging the diode. So here to continue without damaging the diode, Zener diode uses as a voltage regulator. When input voltage varies, the Zener diode its resistance changes, and by creating the mobile charge carriers and keeping the voltage at constant. So that's why here in circuit RL means output voltage is connected, RL is connected parallelly to the output voltage, so that output voltage will equal to the Vz, which is a constant. This is about a Zener diode, and Zener diode used as a voltage regulator.